Hello everybody, this is section 3.5, which we're combining with some talks on section 3.6 and finding equations of lines. And the very first thing we should really be asking about this section is, number one, if we're going to find the equation of a line, what do we have to know? Well, there are really two things that you must know if you're going to find the equation of a line in a plane. It goes like this. You'll note that in some of the forms of the equations of the lines that we've had so far, we've somehow been able to find this information. That information is that we must have a point. So we must have a point and a slope, right? Recall, for example, that when we were talking about the point-slope form of the equation, so the slope-intercept form of the equation in the last section, we said y equals mx plus b, right? In this form of the equation of a line, m is the slope, and we find that b is the location of our y coordinate of the y-intercept. So in fact, we have a slope and a point. So we have all that information, right? And even if we don't have that particular information, sometimes you can get it in other forms too. And we're going to see that we're going to use something called a point-slope form of the equation of a line, which goes kind of like this. If we have a line passing through the point x1, y1, and it doesn't matter where on the line this point falls, and a slope m, then we would write the equation of this line y minus y1 is equal to the slope m times the variable x minus x1. Okay? And in this equation, we have a point and we have a slope. Now, there is a third form of the equation of a line called a general form, and we'll deal with this later, but we have already before, in a way, when we were given an equation in which we had all of our x and y terms on one side and a constant on the other, and then we solved for y to get our function form f of x equals mx plus b. And we saw this in section 3.3. Well, this is the form y equals mx plus b. And so, in fact, it does fit with everything that we've seen. So let's just quickly do an example so we can see this all in operation. Let's say we want to find the equation of the line using the point-slope formula, which is pretty much a very easy formula to use. Y minus y1 equals m times x minus x1. If it helps you to think about it this way, this is actually a formula in which we can fill in certain parts. We're going to take the variable y and we're going to substitute in the given y value. And in the formula, we're going to fill in whatever value we have for m, and we're going to multiply that by x minus the given x value, right? So this is really a fill-in-the-blank kind of deal, and we need to look at what we have. So, okay, we have this line. Find the equation of a line that contains the point 4, -1, and has the slope 3/4. Well, easy enough using this formula. This is saying that our point x1 is 4, our point y1 is -1, and our slope m is 3/4. So if we fill in the blanks right here, we have y minus y1, which is -1 in this case, so we'll take account into that in just a moment. Our slope is 3/4, and x, the variable x, would be minus our x1 point, 4. And without much to do, we actually now have the equation of a line in a very easy form. All we would have to do is substitute in a value of x to find the value of y that goes with it, and write our equation very easily. Okay, so we've got x minus 4 over here. We can re-express this, by the way, in another form if we wanted to. We could isolate y. This is the slope intercept. The nice thing about this is that we can rewrite it in any form we want. We could simplify on the right, for example. Y plus 1 is equal to, if we distribute 3/4 times x minus, let's see, 3/4 times 4 is the same thing as 3/4 times 4 over 1, which is just equal to 3 over 1, or just simply 3. So x minus 3 right here. And if we subtracted 1 from both sides of the equation, we would get y equals 3/4 x minus 4, which we now know to be the kind of equation in our slope-intercept form that has a slope of 3/4 and a y-intercept at the point 0, -4. -4. So, I could do a better -4 than that. Come on, Professor people, let's try it one more time. 0, -4 as our coordinate point. There we go. Very nice and neat. More in the next video.